Imagine adding all the numbers from 1 to infinity and end up getting a negative fractional value. How weird it sounds, but it is actuality. So we will prove it using two methods. The first you must be knowing using infinite series, but the second you must not be knowing. The second will be using integrals, and it will be really amazing to do it by that method. So let's start, and first of all, please do subscribe to my channel. And now let's start. So before understanding Ramanujan paradox, you should know what is a paradox. For example, I will do a social experiment right now, and I will give you all two equations, and in that you have to solve for y. Okay, so just listen. X plus y is equal to 7 and x is equal to 3. Solve for y. Now, the ones who would have not seen the board would have solved this equation. X plus y is equal to 7 and x is equal to 3. So they would have ended up getting y is equal to 4. The ones who did not saw the board, who just listened to me, and the ones who saw the board, they must have thought that I made a mistake while speaking, so they will end up getting y is equal to 6. So now which answer is correct, y is equal to 4 or y is equal to 6? It is really weird to say that this one is correct or this one is correct, because both make sense. If I talk about the people who did not saw the board, their answer is also correct, and the people who said this answer, y is equal to 6, their answer is also correct. So it means that both the answers are correct when taken one at a time, but when we take both of them together, they are not correct, which means a paradox is a statement or a group of statements which when taken one by one are correct, but when taken simultaneously, they don't agree to the circumstances. Like here, you can't have y is equal to 4 and 6 at the same time for a linear equation. If it were quadratic, then it would be possible. So basically a paradox is something like that. More on it later. Basically a paradox is a statement which has two or more parts, and in which the individual parts are correct, but when taken all together they are not correct. They provide contradictions, that sort of thing. Now what is Ramanujan paradox? Add all the numbers from 1 to infinity, and you would expect that this term should diverge. Simply define fx is equal to x, or just leave it. Let the last term be nth, right? Nth term be, what will be nth term? It will be n only. So limit as n tends towards infinity, it is going towards infinity, means this sum will tend towards infinity only. So one thought is that it diverges, right? But the second thought was that from the Ramanujan, it ends up at minus 1 by 12. So now which one is correct? If you see the sum as diverging series, then it can't be minus 1 by 12. And if you see it as minus 1 by 12, it can't be diverging, which means it is a paradox. Individual statements are correct and you can prove them, but when you take all together, you can't say anything. It becomes a contradiction. This can't imply this and this can't imply this, right? So that is a simple paradox, yet it is confusing the scientists since many years. And now we will get into its proof. The first method will be using infinite series, and the second method will be using integral. Which integral? F at 0 plus sum from k is equal to 1 to infinity, f of k is equal to I times 0 to infinity f of it minus f of minus it upon e to the power 2 pi t minus 1 dt. Yeah, it is something hilarious, but what actually it means, it is used to assign values to infinite series. For example, this is an infinite series, right? Okay, so first we come to this. I will erase this for now. So in this, how it goes, you assume a sum. For example, first of all, you have to set it equal to s, just for simplicity. And now take another series, 1 minus 1 plus 1 minus 1 plus, and set it equal to x, just for simplicity. Okay, why we done it, you will see it later. Just do what, multiply by -1, and you will get a minus x, right? And now multiply it, you will get -1 plus 1 minus 1 plus 1 dot dot is equal to minus x. Now just add 1 both sides. When you add 1, you get this, and it is equal to 1 minus x. But what is it? It is equal to x, which means x is equal to 1 minus x, which implies 2x is equal to 1, which implies x is equal to 1 by 2, which means this sum is equal to 1 by 2. Yeah, it is really amazing to see that the set of numbers which has no relation with fractional numbers are ending up at 1 by 2, 1 by 2. Okay, now assume another series, 1 minus 2 plus 3 minus 4 plus 5 minus 6 is equal to y. Set it equal to y. Now what? Now take your this series and just shift it by one terms. 1 minus 1 plus 1 minus 1 plus 1. Does it make a difference? No. And we don't need to do it also. Just take this series and just shift it by one term. 1 minus 2 plus 3 minus 4 plus 5, and it will be also equal to y. Don't you agree? It will be equal to y, right? You have just shifted it by one term. And now just add it. What you will get? 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus dot dot is equal to y. But what is it? It is equal to x, and x was 1 by 2. X is equal to y, which implies y is equal to x by 2, and x was 1 by 2, so 1 by 2 into 2, which is equal to 1 by 4, which means that this series is 1 by 4. Okay, so what, now take this series. What is it? It is 1 plus 2 plus 3. Let us write 2 3 more terms is equal to s. Okay, now take this series, and it states like this: 1 minus 2 plus 3 minus 4 plus 5 minus 6 minus 6, it will plus, sorry, and dot dot is equal to 1 by 4, right? It is correct. Okay, now just subtract it. When you subtract, 1 and 1 cancels, 2 and 2 adds, so 4, this cancels, and it becomes 8 plus 12. And what is it? Take 4 as common. 1 plus 2 plus 3 is equal to s minus 1 by 4. So what is it? It is equal to s. So 4s is equal to s minus 1 by 4, which implies 3s is equal to minus 1 by 4, implies that s is equal to minus 1 by 12, which means we have proved mathematically that it is equal to minus 1 by 12. Okay, so this is really some sort of heavenly thing, because you can't imagine adding the natural numbers till infinity and end up getting a negative number, and that to a fraction. It really is something out of this world, and we will talk more on it later, but first we have to complete the second proof also. So coming on to the next proof, which is rarely used, but it is more sort of, it is a better proof basically, in my opinion. And in this we will use this formula, f of 0 by 2 plus sum from 1 to infinity is equal to I times I is square root of negative 1. I is equal to square root of negative 1. F at it minus f at minus it upon e to the power 2 pi t minus 1 dt, and the limits are from 0 to infinity. Okay, so how do you turn f at k to k? Simply put f at k is equal to k, so it will become the sum of all the numbers from 1 to infinity, right? And f at 0 will become 0, which means the whole LHS, it turns like this, right? And it is what? 1 plus 2 plus 3 to infinity, right? Is equal to 0 to infinity. Put the value of the function it minus minus it upon 2 e raised to the power 2 pi t minus 1 dt, right? And just solve it now. It becomes I integral 0 to infinity of 2 it upon 2 pi t minus 1 dt. Multiply 2I with I, you get minus 2 outside, 0 to infinity t upon e to the power 2 pi t minus 1 dt. Okay, now let's solve this integral to get the value. I'm not erasing this expression. So basically what we had got, minus 2 integral from 0 to infinity of t raised to the power t upon e to the power 2 pi t minus 1 dt, right? We have got this. Okay, so now substitute 2 pi t as x. It makes sense. So dx is equal to 2 pi dt, which implies that dt is equal to dx by 2 pi, right? And t is equal to x upon 2 pi. Substitute the values, and you can see when t is equal to 0, x is 0. When t is approaching to infinity, x is also approaching towards infinity, right? So the limits won't change. It becomes 0 to infinity. What is t? It is x upon 2 pi. And what is this? E to the power x minus 1 into dx upon 2 pi, right? And it becomes, just multiply 2 pi and 2 pi, you get 4 pi square, and it is a constant. Take out of this integral, x upon e raised to the power x minus 1. Now note, integral from 0 to infinity, x upon e to the power x minus 1 dx is equal to pi square by 6. Bose integral, remember it. Okay, if you don't know about it, I will discuss in my later lectures, but not right now because the video will become too long. So it is this. So what we have got, minus 2 upon 4 pi square into pi square by 6. 2 and 2 cancels, pi and pi cancel, and you get minus 1 by 12. And it was equal to sum k is equal to 1 to infinity of k. That is 1 plus 2 till infinity is equal to minus 1 by 12. It's really amazing to approach things by many methods, but this result is something else because you get a negative fractional value, and it's something which blows the mind actually. That will be the right term for this thing. And it is still baffling the scientists because some agree with the diverging series and some say that it is negative 1 by 12. So it is controversial also to comment on that exactly, that I can't say that it is negative 1 by 12 only. I can't say by, I mean, I can't say it because it is controversial still, and the debates are going on it. So if you want to believe, you can believe it as negative 1 by 12, and if you don't, then you can assume it as diverging also, and that's why it is a paradox. So I hope you all liked the video, and please do subscribe to my channel, and thanks a lot for watching it. And please do subscribe to my channel once again.